Here are the factored forms for each part of the fraction. Great work if you got all of these correct. If you made a mistake, that's okay too. Now's a great time to go back and look over your work. See if you can figure out how to get these factors. If not, you can always watch the solution. For our first numerator, we can remove a 2x squared as the greatest common factor. This leaves us with x squared plus 4x plus 3 for our second factor. Now we can easily factor this one by finding factors of 3 that sum to positive 4. That would be positive 3 and positive 1. This is why it's important to find a greatest common factor first. If we don't find this greatest common factor, we won't be able to factor each of these and cancel our factors in the end. For this denominator, we have a coefficient of 1 in front of the x squared term, so we just want to find factors of negative 15 that add to 2. This would be positive 5 and negative 3. For this numerator, the greatest common factor of the three terms is 1, so we just want to find factors of negative 50 that sum to positive 5. The factors would be negative 5 and positive 10, and then we could use factoring by grouping to get our factors of x plus 5 and 2x minus 5. For our last denominator, we can remove a common factor of 6x from every single term. If we factor the 6x as the greatest common factor, we're left with 2x squared plus 3x plus 1. If we distribute this really quickly, we can make sure that this is correct. When we look at factoring this expression, we want to find factors of positive 2 that sum to positive 3. We can use factoring by grouping to arrive at the factors of x plus 1 times 2x plus 1. These factors take the place of this quadratic trinomial. Now we're ready to simplify our fraction since everything's in factored form. Great work.